Hello, advanced math kids. This is your first virtual lesson. I'll put this on the spreadsheet as well. I'll probably email out this first one to all of you. Let's get that off. So just a few reminders. First off, here is where your links are going to go. Right there to all these. You can go back and watch them whenever you want, just like I've done some others for the other classes. You're the last class to go. Hello, Mr. Freeman. Thank you for the textbook. You want to come say hi to the class? No? Okay. So also in the Google folder that I shared with you, there are a lot of different resources that you can use. If there's something that would be helpful for you, please let me know. I'm going to put the PowerPoints of all these in there in Google Slides, a copy of the notes. So all of this will go in there as I make them. So I've just made about your first 4 lessons right now, and also the resources and stuff like that. Also on your resources, your graphing calculator, this equation editor, we'll talk about that later on when we get to matrices. Your matrix lessons will have to be turned in via Google Sheet, but we'll hit that when we have to later on. All right. So 9.3 I think is a pretty good start for us. It should be a lot of review. We covered a lot of this when we were doing the ACT review, but it just kind of talks about the trig ratios of right triangles. So your sine, cosine, tangent, secant, cosecant, cotangent, all of that's coming back up. A lot of it you've already seen. We know the hypotenuse is opposite the 90. Here's theta, your angle, that'd be the adjacent side, and that's the opposite side. So I think this one should go pretty quick. Your lessons will probably be the longest of all my classes just because of the number of notes that we have with that. Your SOHCAHTOA ratios, you know those, sine, cosine, tangent. Cosecant is hypotenuse over opposite. It's the reciprocal of your sine. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. And we'll move on from that. If you ever have any immediate questions, just take a picture or screenshot the problem and the work you've done on it, and then I can kind of pinpoint what you need to do or where maybe you have a mistake. If it's a major question, wait for our class discussion times, which the first one will be next Wednesday at 10:30. I can get on. It's just going to be a continuation of my 10 o'clock one is geometry, and then I'll just have you guys log on, and the geometry kids will log off, or they can listen to, I guess, if you want. So, and then I can cover any other specific questions or reteach anything that you want me to go over. If hopefully there's no surprises on the assignments. There could be. I tried to screen those questions a little bit more closely than what I have in the past. So here we go. Questions like this. Use the triangle in figure 9.2.2. Find the 6 values of the 6 trigonometric functions. And then this question, what would happen to those 6 values if the legs of the triangle were doubled? We'll talk about that later. So let's find the 6. First of all, this is a 3, this is a 4. You need to find the third side, which is the hypotenuse. You may remember if it's a 3 and a 4, this one should be a 5. If not, you use the Pythagorean theorem. It will be the square root of 3 squared plus 4 squared, which will give you 5, square root of 25. If you're ever looking for a leg, it's the square root of the hypotenuse squared minus the other leg squared. Okay? So if you need a leg, you got to take the square root of the hypotenuse squared minus the other leg squared, the other leg, the 2 legs. So leg 1 and leg 2. So the 6 values, sine of theta, sine would be opposite over hypotenuse, so that'd be 4/5. That means the cosecant of theta would be 5/4. Cosine of theta is adjacent over hypotenuse. Remember SOHCAHTOA. And if you got this, jump ahead. The nice thing about videos, you can just jump ahead. Or if you need to watch it again, just back it up, watch it again. Cosine of theta, adjacent over hypotenuse, 3/5. So secant of theta would be 5/3. Tangent of theta, opposite over adjacent. So opposite over adjacent is 4/3. So the cotangent of theta is the reciprocal, 3/4. So if we would double these, we would have a triangle that is 6, 8, and 10. And when you do your ratios, sine of theta, there's theta right there, that would be 8 over 10, which is still 4/5. So if you double anything, it's always going to be the same ratio. So doubling the lengths gives you the same ratio, same ratios. That's what trig ratios are. So for this angle, whatever it is, any right triangle with this angle, these sides will always be in proportion to each other and in this relationship, 4 to 5. So the opposite over the hypotenuse will always be 4 to 5 with that angle. Okay, these values right here we've seen before. This was also on kind of this chart right here. Hopefully you still have that. If not, let me know. I can email you a copy. These come from our 30, 60, 90, and 45, 45, 90 triangles. So remember a 45, 45, 90. If this is 1, this is going to be root 2. That's root 2 times as long as a leg. A 30, 60, 90. If that's 1, the hypotenuse is twice as long, and that leg is root 3. This would be 1x, 2x, and x times the square root of 3. X root 2, 1x. Okay. Here are your complementary functions. So if theta is an acute angle, then the following relationships are true. The sine of 90 minus theta, that is the complement of the angle. So 90 minus theta gives you the complement of the angle. So you notice the sine of the complement is called the cosine. That's where the co comes from. And cosine is the sine of the complement. And we have a guest presenter walking in right now. I'm going to let him come say hi. This is advanced math. So.
All right, advanced math.
Yes.
Awesome stuff. Mr. Leitner's going to do a great job of keeping you up to speed here, I can tell. So, always good to see you, students, and good luck on everything. Let me know if you need anything.
Okay. Thank you, Mr. Bowden. So, they're my last. I made videos for all the other 3 classes. Save the best one for last,
awesome.
I guess. Or the longest ones. Okay. So, tangent and cotangent are your cofunctions. So the tangent of a complement is called the cotangent of the angle. So secant and cosecant are your cofunctions. So how this works, let's say if you have the cosine of 40 degrees, that would equal the sine of 50 degrees, that is 90 minus 40. That's 90 minus theta. Okay, 40 and 50 add up to 90, so those two are equal. You could have the tangent of 10 degrees, that would equal the cotangent of 80 degrees, complementary angles. So the co stands for complementary. The secant of 45 degrees would equal the cosecant of 45 degrees. 45 is a special number. That makes your isosceles right triangle. That is this one right here, isosceles right triangle. So your sine and cosine are the same values. Okay, so if the cosine of 60 is 1/2, then what is the sine? Then what is the sine of what angle is also 1/2? Okay, editing error. Then what? Then the sine of what angle is also 1/2? So if the cosine of 60, the sine of what angle? That'd be the sine of 90 minus 60. So that'd be the sine of 30. Should equal 1/2. So cosine of 60 is 1/2, sine of 30 is 1/2. If tangent of 42 equals x, then what is the cotangent of 48? Well, you notice 42 plus 48 equal 90. So it also has to equal x. Same thing, because they're complementary angles, they have to be equal the same thing. If the sine of 20, evaluate the sine of 20 if you know that the secant of 70 is 2.9238. Alright, so the secant of 70 is 2.9328. Sine and secant are not on the same line. Okay, sine and cosine are going to be the same values. Now these are complementary. But remember, secant of 70 has to equal 1 over the cosine of 70, because it's the reciprocal of 70. So this is 1 over 2.9238. So 1 divided by 2.9238 is 0.3420. 0.3420. Okay, and that is what the cosine of 70 should equal. Okay, because the cosine of 70 would equal, I should have done this. That's kind of bad. Cosine of 70 would be 1 over the secant of 70, which is 1 over 2.9238, which is 0.3420. Okay, so we need the cosine of 70 is 1 over the secant, so it's 1 over 2.9238, which would be 0.3428. So now that's what the sine of 20 would equal, because 20 and 70 are complementary, they add up to 90. Okay, hey, got another guest presenter. This is going to be a nice long video for you all. Okay, he's going to come teach some advanced math.
What's going on?
This is, you got Dylan and Luke and Dawson and Kale and
Oh, I'm sure they want to see
Eddie
me.
and Jaime in here, so they definitely do. So we're doing some trigonometry right here, some sine, cosine.
It's been a while.
Tangent.
I'm not for sure I can help you too much with that one.
So,
all right.
yep, that's what we're getting after here.
Well, have fun, guys. Take
Always.
care. Stay healthy. Miss seeing all of you around here. So, be in touch.
Okay. Thank you. Okay, example 3, function, fill out the box. So they're going to give you an operation, and either a degree, radian, or a function value, and they want you to just fill in the rest of them. So the sine of 30 is where this is going to come in handy. Okay, so sine of 30 degrees, we know that is pi over 6, so we're just going to fill in pi over 6. And the function for the sine is the y value, that should be a half. So sine of 30 is a half. So you're just filling these in like that. Sometimes with this, when we have multiple examples, please stop it before I get to those and try to fill them out yourself, or try to write down the answers. And from that, then you can come back and check to see how you did it. So the secant pi over 4. Pi over 4 we know is 45 degrees. Okay, so the secant of pi over 4 is root 2. Yay, go chart. Cotangent, we have root 3 over 3. So I'm going to look for a cotangent root 3 over 3 right there. So that's 60 and pi over 3. Okay, there we go. Here are some more identities. Sine, we know, is the reciprocal of cosecant. Cosine is reciprocal of secant, so forth and so on. We know those. These are a little bit new. Tangent, remember me saying tangent is y over the x. So on the unicircle, tangent is y over x, but y is associated with sine, x is associated with cosine. So tangent can be written as sine over cosine. Cotangent is a reciprocal, cosine over sine. These three right here we'll see a little bit and use some. Sine squared theta plus cosine squared theta equals 1. Now how you type this in the calculator is you have to hit the sine of whatever it is, 40, close it, put another parenthesis around that, then square it. Okay. Let me check that. Nope, you get the same answer. Okay, maybe not. So if I do sine of 40 squared, 0.555, and the quantity sine of 40 squared, 0.555. So you can just put the squared on the outside like that. That's how you do a sine squared theta. Plus cosine of 40 squared should equal 1. So these are all your Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. Okay, use the given function values and trigonometric identities, including cofunction identities, to find the indicated trig functions. Okay, so they're going to give us two pieces of information. Try to do this without the chart and calculator. That is the goal. Okay, so using what we know, we want the sine of 30, and I know that 30 and 60 are complementary. So if the cosine of 60 is 1/2, the cosine of 30 has to be 1/2. Same thing here, cosine of 30 has to be the same as the sine of 60. Cosine of 30 has to be the same as sine of 60. 60 and 30 are complementary, so that's root 3 over 2. The tangent of 60. Remember, tangent of 60 can be written as the sine of 60 over the cosine of 60, so that is root 3 over 2 over 1/2. So that is 2 root 3 over 2, which is root 3. So the tangent of 60 should be root 3. Cotangent of 60 would just be the reciprocal of this, 1 over root 3, which is going to be root 3 over 3 once you rationalize your denominators. Take top and bottom times root 3. Okay, and of course, now you can check it with your chart, make sure you did those right. Okay, same sort of situation. Cotangent of alpha is 5. Now all these, that's the only symbol I could find for alpha with that little tick mark up there. So cotangent of alpha is 5. Tangent of alpha would have to be 1 over the cotangent, which is 1 over 5. So yeah, 1/5. The tangent would have to be 1/5. So what that means here is on the top, let's check some of those other things. On the top, that is what the sine of alpha is. So from the top, we know the sine of alpha is 1. The cosine of alpha is 5 because tangent is sine over cosine. Sine over cosine. So sine of alpha has to be 1. Cosine of alpha has to be 5. So cosine of alpha has to be 5. The cosecant, that is 1 over the sine of alpha, and that has to be 1 over 1, which is 1. And now the cotangent of 90 minus, so the cotangent of the complement. So the cotangent of the complement, if you remember, I had to think there for a little bit, the cotangent of the complement should equal the tangent of the original angle. So if the tangent of the original angle is 1/5, this should also equal 1/5, your complementary properties there. Okay, we're making progress. A couple more. Let theta be an acute angle such that sine of theta is 0.6. Find the values of cosine and tangent using the trigonometric identities. Okay, so I know sine of theta equals 0.6. We want to find the cosine of theta and the tangent of theta. So your identities, that Pythagorean identity says the sine squared of theta plus the cosine squared of theta should equal 1. So I know that the sine of theta is 0.6. So 0.6 squared is how that would get plugged in, plus cosine squared theta should equal 1. So 0.6 squared would be 0.36. So cosine squared theta should equal 1 minus 0.36. Cosine squared theta, that would be 0.64. And now you square root both sides, and you get cosine of theta would equal 0.8. So you use some algebra and your trigonometric identities to get the cosine of theta 0.8. And now we know tangent of theta should be the sine of theta over the cosine of theta. That's 0.6 over 0.8, and that's going to be 3/4. Okay, 0.6 divided by 0.8, 0.75. Okay, so 3/4 on that one. Find the values of theta in degrees and radians. You only need to give answers in the first quadrant. Do not use a calculator. but it doesn't say you can't use your chart. So sine of theta is a half, only do in the first quadrant, so stop right there. Sine of theta is a half in degrees and radians, so half is 30 degrees and pi over 6 radians. The cosecant of theta is 2, so cosecant of theta is 2 in the first quadrant, same answer. 30 degrees, pi over 6. Hopefully you see where I'm getting these from. Cosecant of theta is 2 root 3 over 3. 2 root 3 over 3. Cosecant again? Yeah, cosecant. 2 root 3 over 3. So that'd be 60, which is pi over 3. Sine of theta is root 2 over 2. Root 2 over 2, which is 45. So 45 degrees, that is pi over 4. Okay, that's all you got to do in there. Use those charts for those questions. Many applications involve a process called solving right triangles. That is just finding all side lengths and angles. Acute angles. Aren't they acute? Okay. That's just a note. When they say to solve it, you have to find all the side lengths and the acute angles. These are just notes. Angle of elevation. So when you have a right triangle, if you're down here looking up, that is an angle of elevation. And if you're up here looking down, that is an angle of depression. If imagine you're on the earth looking up to an airplane, you have an angle of elevation. If you're up high like on a canyon or a tower or something like that looking down at something, you have an angle of depression. Depression goes down because it makes you feel sad and down. Oh, just one page on this last one. We're almost there. Okay. Surveyor is standing 50 feet from the base of a large tree, as shown in figure 9.26. Okay. So that is not the same picture for that question. The surveyor measures the angle of elevation to the top of the tree as 78.3 degrees. That is correct in there, if you can see that. How tall is the Washington Monument? Okay, we are not 50 feet from the base of a large tree. We are 115 feet away from the base of the monument. So this is just your right triangle trigonometry. So we want y. Y is the opposite side. So what we have here, draw it bigger for you. We have 78.3 degrees. You have some very precise measuring tools as you walk around the Washington Monument, obviously. 78.3 degrees, that's 115 feet. You want y, that is going to be a tangent ratio. That is opposite and adjacent. So the tangent of 78.3 equals y over 115. So y multiply the 115 over 115 times the tangent of 78.3. Make sure you are in degrees. 115 tangent of 78.3, and we get, make sure you are in degrees. Yeah. 555.3 feet. And that'd be it. Okay, so as you go through assignment, let me know what questions you have. Anything that's like, oh, you didn't cover this, just hang on for the class time and I'll go over it with you and see what it is. Hopefully there's no major surprises. But good luck. I'm going to sign off and get this done with. So miss you all. Hope you're doing well, staying active, get outside, and exercise still. Okay.